So a particle is thrown with initial velocity 10 root 3 meters per second, and gravity is down, and the acceleration of gravity is taken to be 10 meters per second square, and the angle of projection is 37 degree. Now from the point of projection there is a long vertical wall which is at a distance of 24 meters from the point of projection. Now as the particle goes this way, it collides with the wall, and the collision of the particle with the wall is elastic. How far from the wall will the particle land on the ground? So after hitting the wall, it will come back on the ground. So where it will fall, that we have to find. Now the first thing you have to understand is what is the meaning of this elastic collision with the wall. So understand that if this is your wall and a particle hits the wall this way with speed v, then what it means is it will rebound at the same angle with the same speed, provided this wall is considered to have infinite mass. And in such problems, the wall's mass is considered to be infinite. So the speed with which the particle hits the wall, with same speed it will rebound at the same angle. That is the meaning of elastic collision. Which means if you take components of this speed, this is theta, right? So this is v cos theta, v sin theta. And if you take components of this speed, you can see this is theta, means this is also theta. So this is v cos theta, this is v sin theta. So you can see the vertical velocity, the vertical component remains same in direction. So if it is down, after collision also it is down. Whereas the horizontal component after hitting the wall will reverse. So if this is 10, this will be minus 10 because this is opposite direction to this. So that is the meaning of elastic collision with a wall. So now when this particle goes and hits the wall, let's say the particle was hitting the wall while it is going up. That we don't know right now, we will see later. But let us assume the particle hits the wall while going up. So this is the picture just before hitting the wall. So just before hitting the wall, its velocity is this side, okay, up. Up here means at an angle. But so if you take components, these are the two components. Now what happens after collision? If it is elastic collision with the wall, I told, this velocity will reverse after collision, and this velocity will remain same. So now your new velocity will be this side, right? And since magnitude will be same, it will follow the same path but this side, because now the resultant velocity is here. So whatever path it would have traveled if there was no wall, it would have traveled this path, right? Now since velocity here after collision, this velocity is reverse of this and this velocity is same. So vertically whatever happened here will happen here also vertically, and but horizontally it will reverse this side. So this same path will be traveled in backward direction. So that is what happens in projectile when it hits a wall. I hope that is clear. Meaning, if let's say we all know this is R range, if there was no collision with the wall, this is the maximum height. So that maximum height will be same here also. And from, let's say this is R1, this is R2, then this distance from the wall to here, that will be R2, because this path I should say will be identical to this path. except it will be reversed. It's like reflection from a mirror. Okay. Similarly, if there was a wall here and particle hits the wall while going down, then here its velocity just before hitting will be down like this. So this will be the components. What happens, I told you, because of elastic collision, this velocity will be reversed. This velocity will stay same. So now the resultant velocity will be this side. So now whatever it was supposed to do this way, it will now do here. Understood? So if this is R, the range without collision, and this is, let's say, R1, then this will be also R1. Okay, so this small thing we need to remember. And I hope now you have guessed that if it exactly hits the wall when it is horizontal, when it's traveling horizontally, meaning if you keep the wall at its maximum height location, so this is the maximum height location of the projectile. So if you keep the wall here itself, then its velocity before hitting the wall will be this side, and that velocity will be reversed, and since the magnitude is same, it will cover the same horizontal distance, right? So same horizontal distance it will cover, so it will come back to the same point. So if you want the body to retrace the path, it should hit the wall perpendicularly. Okay. So in this question, first we should see what is the range of the particle. So the formula for range is u square sine 2 theta by g. And since here theta is 37 degree, let us write this sine 2 theta as 2 sine theta cos theta by g. Now what is u? 10 root 10. So square of 10 root 10 will be 100 into 10 sine theta. So 37 degree. Sine 37, you know that famous triangle, right? If this is 37, this is 3, this is 4, this is 5. The Pythagorean triplet, the first Pythagorean triplet, right? So using this, you can find sine 37 to be 3 by 5 and cos 37 to be 4 by 5 divided by g is 10. 10, 10 cancels. 5 2s are 10, 0, 5 4s are 20, 4 2s are 8, 3 4s are 12. So this is 96 meters, right? So the range of the particle is 96 meters, and the half of this will be what? Half of this 96 meters would be 48, and this wall is less than 48, right? So therefore this projectile will hit the wall while going up, remember, not while going down. If it was at 48, if the wall was at 48 meter, then the projectile will hit the wall while it is going horizontally, and therefore it will come back to the same location, isn't it? So we came to know that this particle will travel a horizontal distance of 96 meters if there were no collision. But wall is kept at 24, which is less than half, so the wall is somewhere here. So now this is no longer the actual path. This is the path it would have traveled. And because of collision, what we learned just now? Same path here will be traveled in opposite direction, like reflection. Okay, so it will go and reach somewhere here. Now this is given how many meters? 24 meters. So this distance would be 96 minus 24, which will be 72 meters, isn't it? And therefore, if this is 72 meters, this is also 72 meters. From the wall, the particle will fall at what distance? 72 meters. So this is the answer of where the particle will land from the wall. But if they ask from the point of projection, from here if they ask, that will be obviously 72 minus 24, isn't it? So that would be the answer. And this will be 58 meters, right? No, 48 meters. Okay. And if they ask time of flight, time taken from here to here to here, that will be same as time of flight from here to here, because this path is identical to this path. You can see from here to here, this is the vertical distance covered. Here also from here to here, this is the vertical distance covered. And we know that the vertical velocity remains same during elastic collision. So if vertical velocity and vertical displacements are same, time taken also will be same. From the formula, Sy equals to Uyt minus Gt square, isn't it? So if Sy and Uy are same, T also will be same. Okay. So total time from here to here to here to here, that will be same as time of flight, which is 2u sine theta by g. And if they ask maximum height, then that maximum height and this maximum height are also same, u square sine square theta by 2g. Okay. Let us see the next question. A particle is projected horizontally with a speed of v. Okay, you can consider this as the initial speed also, u. Normally we write u for initial velocity. And it is thrown horizontally from a height h. Now they are saying this particle returns to the point of projection. It comes back to the same point after two elastic collisions, one with the wall and one with the ground. We have to find the total time of flight for this to collide with these two and come back here. Now, why will it come back here? You have to think carefully. So some of you may think maybe it will collide like this, then it will collide like this, and then it will reach here like this. Now I'll try to show that this is not possible. But why this is not possible? For that, just like we learned what happens when particle hits wall, how its velocity reverses. Try to see what happens when a particle hits a floor. So suppose you are throwing something horizontally like this. It comes this way. Now before hitting, its velocity is this way, right? So it has two components, y component, x component. Because it is elastic collision, now this will be reversed and this will stay as it is. So this is same, this velocity remains same, and this velocity is now reversed. But remember, magnitudes are same. So therefore with this velocity, it will gain the same height. It will gain the same height. And with this velocity, it will travel the same horizontal distance. So therefore it will go up to here. So if this is h, this will be h by symmetry. And if this is r, this will be r. So this is how the motion will look symmetrical if the collision with the floor is elastic. So from here to here, the vertical height, and from here to here, the vertical height will be same, because y component of velocity is same, isn't it? And when it reaches here, its velocity will be again horizontal. And because this y component of velocity is reversed, it will go up, and x component of velocity will remain same. So during that time, this covers horizontal distance r. In the same time, this will also cover horizontal distance r. Okay, so this is how the path will look after collision. Try to remember this. So here, why this is not possible is very simple. So we are throwing the particle first horizontally, and we have kept wall here. So it will go down, and whatever it was supposed to travel here, that it will travel this side, that we have already learned. Now if this wall was not there, it would have gone this way, reaching the same height, isn't it? Now from here, because it is starting not from here, because this wall was there, right? It will go same height, but that distance is, let's say, this distance is, let's say, r. Then this will be also r, I told, isn't it? And therefore from here to reach this same point, it needs to travel r distance back. But there we don't have this thing, right? So it will travel something like this. So at r distance it will not reach the point of projection. I hope you understood this part. So after hitting the wall, it would have gone the same distance like this, provided it starts from here. But due to this wall, it will reflect and it will start from here now. So from here, the path will look symmetrical to this path, okay, after collision with the floor, because whatever velocity here it has, same velocity here it has, but in opposite angle, and whatever y component it has, same y component it has, and whatever x component it has, magnitude wise this also has same x component but this side. So from here, if it travels r distance and h height, from here also it will travel r distance and h height. So therefore it will not reach this point. Okay, so I hope you understood why this is not possible. So in fact it cannot hit anywhere like this and come, not possible. So the only way this is possible is, I think you may have guessed, that it must hit exactly the corner. So when it hits the corner, it has velocity before hitting this way. These are the x and y components, right? And after hitting, due to this wall, this velocity will be reversed, and due to this floor, this velocity will be reversed. Therefore, it was supposed to travel this way. If there was no wall, it would have traveled this way, same height and same range. But now because this floor is there and this wall is there, this velocity is reversed here, right? This velocity is reversed here due to the wall. So resultant velocity will be here. Since the magnitudes are same, horizontal distance what it was supposed to travel here will be same as here, and vertical distance will be also same as here. So therefore it will reach the point of projection. So they could have asked an interesting question by saying where it should collide for this to happen. It should collide at the corner. And now time taken for the complete journey will be time taken from here to here plus time taken from here to here. And time taken from here to here, we can use the formula Sy equals to uyt plus half ayt square. So from here to here, this path, this is your actual displacement. This is y component of displacement downwards. So the y component of displacement is this h. Down we will take positive h. It is going down, right? So down we will take positive h. Y component of initial velocity is 0 because initial velocity was completely along x-axis, and acceleration along y-axis is due to gravity, down only, g into t square, right? So time taken will be under root 2h by g. So answer will be twice of this, 2 into square root of 2h by g, because this time taken will be same as this time taken, isn't it?